f of n is 2n square plus 3n plus n or 1. So in this case you can consider c1 as something, it should be greater than that one, right? For c1 it should be greater than this one. So you can consider c1 as 2 and c2 as, this is for lower bound and this is for upper bound. Upper bound would be, as I have already told you, you have to just to be most on the safer side, you have to just add all the constant whatever is present, or any of the function, just try to take as big constant as possible. So it would be a 7, right? So your function will always be between, f of n would always be between c1 times g of n and c2 times g of n. Right? Are you getting it? So it would definitely be less than this 7n square always and greater than 2n square always, your function. Right? Any doubt? So this gives you the tightest bound, like the most accurate answer would be given by your theta. So this is this notation we usually use whenever we try to get, and over here if you will be taking the big O of both the things, big O of this one and this one, then you will be getting n square only. Are you getting it? I can see most of you guys feeling sleepy, so just participate, just ask questions, so that because I can understand it is really very basic things, but we need to cover so that we can go ahead. Okay, any doubt so far? Anyone is having any doubt? So I can say like the running time of any of the algorithm would be, if we are summing up all the fragments of the program and whatever the time complexity being taken by individual fragments, if we can sum it up all, then that would be the time complexity of your entire algorithm, right? So let's take one example and then so suppose I am taking this example. So make this point clear, like whenever you are calculating the time complexity, it should be for worst case, like for very large input, first thing. Second thing is for worst case, and third thing is the entire time complexity of your program should would be the time complexity of individual fragments. Okay, so for simple statements it would be big O of 1 would be big O of 1, right? For simple statements, that is any constant time, that is unit time, you can consider. For loops, it would be big O of n. N means any input. So don't be like very much inclined towards n. Suppose if I am asking you what would be the time complexity of suppose you have to calculate the area of this particular room. Now there would be this would be length and this would be width or length whatsoever. So if in that case you can consider time complexity as big O of A, which is area, if you want to show something over on this complete surface, so that would be this, or you can take length into width as well. Okay, so this is same as this one. It is not like it is the time complexity of this one would be n square. So it is not like that. Like you have to consider, you have to always analyze what you are thinking, what you are calculating. Over here, area is same as this length into width. So don't be very much like think about this n only, because if you would be considering it as n, then it would be n into n, that is n square, but it is not. It is linear function. Okay. So for single loop and for multiple loops, it would be for nested loops. So it depends on how many loops are there. Okay, how many loops are there, it depends on that. And for branching, I'll be covering everything. For how when we'll be getting problems like which is based on branching. So over there, usually go for exponential time constant. That is branches to the power depth. So this is usually the general time constant. This is general time complexity of any of the branching functions. Like how many branches it is being made at every node, and what is the total depth of the branch. So that I will cover. So that being said, let's take example. Suppose we are taking this example. There is a function f, and in this function there is one for loop with certain conditions. You have to, there will be some simple statements. Okay. And for one another for loop, and in this for loop there is another for loop. I am giving constraints. Make some simple statements. Okay, so in this case, if we have to find out the time complexity of the complete program, so how we'll be calculating? So everyone just like if you have got what I have explained so far, so just try to find out the time complexity of this function.
N square.
N square. Okay, how can anyone explain this? Yeah. Sorry?
The nested loop will obviously take more time than the single loop.
Right.
So we'll compute the time complexity of the nested loop,
Okay.
which would be more than the single loop, and the total time complexity of the nested loop would be n square.
Right. That's good. So this one is like if you will be analyzing this one, then you will be getting time complexity of this part. That is the first part. It would be F. You go of L, and this one you will be getting. See, for every it depends. Like I'll be taking lots of variations of the this one, where you will be calculating some different time. You will be getting some different time complexity. But for now, for every over here, for each value of this one, you have to perform this. Okay, so always try to think when you have to add and when you have to multiply. Okay, let me tell you, this is big of n, and this one would be big of n square, right? So the entire time complexity you will be getting something like big of n square plus n, right? Right, correct. So over here, why you are like this one would be executing n times. This one would be executing n into n times. Right? This one would be executing for like j value would be for each j value you have to perform this thing. Getting it? But over here, this is separate, this is separate. Like for each value of this one, you have to say you have to just execute this simple statement. But over here, this simple statement which is getting executed, sorry. This one. So this simple statement would be, see, for one value of j, this for loop will execute n times. Again, for next value of j, it would be executed n times, and so on, so on, so on. So when you have to multiply and when you have to add, that you have to consider clearly that whenever you are executing something for like for this much part, you have to execute every value of j over here. So it means that you are multiplying something, and over here it is not like only simple statements are getting executed for each value of this one. There is no iteration, there is no, and this one is completely independent of this one. So what you have to do is, if you want to calculate the entire time of complexity, then this would be some, like suppose if I'm taking this one as a and this one as b, then it would be big O of n and big O of b square, and then this time complexity would be a plus b square. Okay. Now again in this case you have to consider most, like you over here, if you don't know the relationship between a and b, then you can't just eliminate or drop this term. Why? Because there may be possibility that a is itself is as area, and area could be like multiplication of two numbers, and those two numbers are really very large. So in that case you can't say directly that big of a plus b square, since it is like polynomial which is having higher power, then in that case we can eliminate the lower order. This never happens. Always think, if there are multiple variables, then you have to consider all the variables, unless there is any relationship which is given between those variables. Suppose there are 5 to 6 variables or 4 variables, and there is some relationship between those variables, then you can't directly eliminate other variables. Okay, so this is the point in which you have to make. Any doubt in this one, like for variables? Because this is the point where usually most of the programmers usually lag behind, or those who are starting. Because always try to apply logic, because there may be possibility that a is having very big number and b is very low. B is like increasing linearly and a is increasing with high rate, and in that case you can't drop the return. Okay, so did you got this point? When you have to add the time complexity, when you have to multiply the time complexity, when you have to like if there are parts, like the entire program is divided into chunks, then like the entire time complexity would be the addition of individual time complexity of individual chunks. Okay, any doubts so far? Anyone is having any doubts so far? Okay, you got? So let's take one more example, and then we'll switch to some other topic. Now I'll be taking some good questions. So just be ready to take really strong questions. Suppose there is dependency between two operators. Are you done with this one? Anyone is having any doubt in this one? Okay, so because now we'll be taking some good questions, so the level of the problems will be big. I'm writing directly the logic only. Okay, suppose this is the problem. Now you have been asked to calculate the time complexity of this problem. Very easy, just try it out. Think. By the way, hello.
Yeah, I'm not a student, I'm just here.
Okay. Can anyone explain this? Anyone? Yeah, explain.
As for every I, maximum times the J loop will execute n times.
Okay.
So we are multiplying, we are taking the maximum number of times we need to do this.
Okay.
The loop is running.
Are you considering some other changes which I have made over here? Like, is there any difference between this one? If I am writing inner loop as for I is running from some other from start to end, and then this one and this one.
There will be a slightest change, but that would be negligible to the comparable to the higher values of n.
Okay.
So we are not considering for that slightest change.
So if I would ask the equation of this time constant, rather than directly giving the final answer, is there any like equation?
N square minus n into I.
And square minus
Plus
n into
नहीं n square minus n I.
n
I.
I. This one. Anyone else? Yeah.
Actually, we can relate this to the sum of n integers.
Right.
For I is equal to 0, the first iteration, j is from I plus 1 to n. So, n times that in a for loop runs. Then when n is equal to 1, it runs n minus 1 times.
Right.
Then n is equal to n minus 2. Like that it goes n minus 3, n minus 4, all the way to 1. So summation from 1 to n is n into n plus 1 by 2. So that's n square.
So suppose if we are taking example n as 5. Okay. So what it is doing is for 1, it will be taking from 1, 1 2, 1 3, 1 4 and 1 5, right? Then this would be 2, this is 2, then it would be 2 2, it won't be taking this 2 1, right? 2 3, 2 4, 2 5. Similarly 3 3. So as you can see, this is taking the upper half of, suppose if we are considering this as a matrix, complete matrix, So it is taking only upper triangular matrix. It is adding only the upper part of the matrix, isn't it? Right? See, over here how many dependencies would be there? 5. Okay? Or in any case this would be ni. Over here how many are there? 4, which is n minus 1. Over here 3. Similarly till 1, the last one. So what you have to do is time taken by this, the complete time would be summation of all the chunks. As I have already told you, the time and the entire time complexity of any problem, any algorithm would be the time taken by the individual parts of your complete algorithm, right? So the net time complexity, if you would be calculating, then it would be n plus n minus 1 plus n minus 2 plus so on till 1. So it is nothing but sum of n natural numbers, which is n into n plus 1 by 2. So the equation which we will be getting would be n square minus n by 2, right? So if you will be taking the, like as I have already told you, if n is very large, then you can eliminate this one, that is you have to eliminate you have to take only dominant terms. So over here which one is dominating, n or n square? So n square is most dominating term, so you have to consider this one only. So this time quantity would be big O of n square. Okay, so let's take some more example. I have one. Anyone is having doubt in this explanation? Any doubt, any question? If you are not getting anything, just ask directly. Because considering everyone is getting and you are not getting, it's okay. Okay, so let us start. Suppose there is a function f and this function is something like okay. Now calculate it out.
What is the value of P?
Independent of n. That is again one other variable. P root n. P root n. P root n or anything else. Try out this one. Outer loop, it has to perform this one, and it could be completely independent of this one.
So that's j equal to I plus 1 to p, right?
Yeah.
Yeah. So when I is 1, it
Okay,
takes
okay,
p
the
time.
condition, yeah, correct.
P is less than or than 0.
So there would be constraint that
That's right. You just have to look at p and root n and see.
p is less than root n. Thanks.
No, it's still not set exactly.
This one.
Yeah, because
Minus for the, I think this one. Suppose if n, this is root n, so root n plus 1 to root n, so it would be plus 1.
No. Irrespective of the condition, the general, if you write the general form, then from that different conditions will arise. You cannot just say from seeing the loops.
This one independent, see, over here we can take, like, at max this would be root n, right? So for this could be root n plus 1 to root n plus 1, if I am taking this example. Greater than or equal to it could be. Sorry. Yeah.
What we are saying is, irrespective of the condition, that would be the answer. Right?
This one.
Yeah, there will be some extra terms.
Okay.
Like if you write it in the sigma notation,
Mm-hmm.
so inner sigma will give the answer p minus I.
Mhm.
Like if you just write it in the sigma notation, sigma p minus I, where I varies from 1 to n.
Okay.
1 to root n. And so this gives p root n minus root n into root n plus 1 by 2.
This one.
Yeah, like integer part of root n that we are.
Okay.
So this.
but this is p root n minus n, but this is true only when you assume that p is greater than I. So p should be greater than root n.
Right.
If p is greater than root n, that inner term is positive, and so you can add it up, and this works.
That is why I was like
Yeah.
putting some constraint over there. But instead of this one, this would be the general.
Yes. So it's p root n minus n,
Right.
and if you are assuming that p is greater than root n, then p root n is greater than n, and so it's fine. P root n is correct.
Then there won't be any issue. Okay. Has everyone got this one? Like those who were fixed with p root n. Generally, if there is this constraint, then this would be okay. But if there is no constraint, then you have to look out the second part as well. Like
Let's just take an example when p is much smaller than root n. Let's say p is 10 and n is 10 power 100. Right? So then
150 or something like that.
yeah. So when I becomes greater than p,
So it
the
won't
inner loop runs only constant number of n.
right.
So so actually even this is not right. So it's p root n plus n in that case. So then that becomes the overbearing term.
So in that case, this J would be like something like
J equal to 20 to 10 will not run at all. So but still it takes like this plus one time.
but this condition won't satisfy.
Exactly. But it will take one time to like constant time to check that.
Yeah, every time it will cheat.
Exactly. So at least the root n term will come from that.
Right. Because over here, as you can see, this one is dependent on this one. So we can't directly say, suppose if in any case, if it is running from this one to this one and p's value is greater than the root n value. So in that case, this will fall in the.
So, but then P would become negligible in P root n as well, because P would be much smaller than root n.
So, no, but you can't directly say because p could be again a large number and root n, sorry, n could be again very large number.
But P is much smaller now.
But you can ignore terms only when they're additive, not when they're multiplicative. So something like root n into n is not same as n,
N.
but root n plus n is same as n.
So as I've already told you, this big O of A is not same as big O of AB. Because over here, like the area, it is completely dependent on length and width, other parameters as well. So like whenever we are adding two, and that too if two of the terms getting added, and over there both are independent of each other. You don't know the relationship between them, then you can't directly ignore the other term. Okay.
We are saying that when I is greater than P, so the statement will not run.
It will not run, but will
Yeah.
speak exactly.
One time.
It will
It
take
will
one
just
second.
compare
So it will
with-
take only till I becomes as large as P.
Okay.
In which case it is P plus P minus 1 plus P minus 2, which is P square.
Hmm.
And then whatever is there is constant time. So that is in the case when root n is greater than P. So that's why we don't want to go into that complication. So we say, okay, root n is less than P. And then it comes out to be nice enough.